Hello everybody, my name is Jose Roca. I'm a mechanical engineer. Today I will guide you through this presentation concerning rolling bearings. I hope you will enjoy it and we will start in a few seconds. So let us start with this presentation, types of rolling bearings depending on the load. I want to spend a few words before we start. The product range of rolling bearings is very wide. So one way to structure them, and this is what we see here in the slide, is to arrange them concerning their capability of forces or load absorption. Let us take a look here on the left side. These are bearings where the predominant load is radial. For example, here are some bearings: the groove ball bearing, the cylindrical roll bearing, self-aligning roll bearing, self-aligning ball bearing, and needle bearing. If the predominant load in our technical construction is a radial load or radial force, we can use this type of bearings. So if we take now a look on the right side, and our construction, we have combinations of forces, or better say loads, radial and axial loads. We can use the following bearings: the spherical roller bearing, the cross roller bearing, the groove ball bearing, and the angular ball bearing. Below, here in blue, we see bearings that can absorb axial loads: the axial tapered roll bearing, the axial cylindrical roll bearing, the axial groove ball bearing, and the axial needle ball bearing. Now we want to go on and we want to speak about types and construction of rolling bearings. For this, we will take a look on the most common rolling bearing in the market. This is the grooved ball bearing. The groove ball bearing consists of the following elements. We go on from left to right. We have an outer ring, we have a cage, we have rolling elements, in this case balls, and we have an inner ring. Let us take a look at the cage. The cage is therefore to positioning the rolling elements in a defined position and to avoid that the rolling elements, in this case balls, have a contact between them. The rolling elements has the following function. They transmit the forces from the inner ring to the outer ring, or in opposite direction, from the outer ring to the inner ring. So now let us go on with types and construction of rolling bearings. Here we find some pictures taken from 3D drawings about these bearings. On the left side, we will begin with the axial ball bearing. The axial ball bearing, remember it from the first slide, can only support or transmit axial forces. In this case, the rolling elements are balls, but they can be also, for example, rollers. If we use rollers instead of balls, we will increase the axial load capacity. So on the same line and following with the needle bearing, here we can say the following. Needle bearings are used where we have a small mount space. They mount also rollers, we see it here. That indicates that they have a high radial load capacity. Another distinguished element, if we compare it with the groove ball bearing, is that in many cases they are mounted without inner ring. Let us go on the left side below with the spherical roller bearing. This is a very special roller bearing, and it is used, for example, when we have a high deflection in our shaft, and also when we cannot assure a correct alignment of the shaft centers, taking into account the standard clearance tolerances in radial and axial direction of common bearings. Now here on the following with the angular ball bearing here on the right side, I want to say the following concerning this. The bearing can support axial and radial forces, but I want to point out that a single angular ball bearing can only support axial load from one side. This is indicated here with this red arrow. So normally, if we want to support a shaft where we expect high axial loads and we are not sure concerning the axial load direction, we adjusted one against a second bearing. So now we come to a typical technical application of rolling bearings. Is a shaft bearing by using two groove ball bearings. Normally we have a fixed bearing and a floater bearing, like shown here in this picture. Here on the picture we see these two groove ball bearings, and we want now to take a look on the fixed bearing. To achieve that the fixed bearing fulfill the task of supporting radial and axial loads, we have to fix the outer and inner ring of our ball groove bearing in axial direction by, in this case, a lock ring, and also the outer ring we must fix it in axial direction by using the housing cover. In case of the floating bearing, here on the right side, we have only to fix the inner ring. The axial movement of the outer ring is beabled. That means that the outer ring can move. This is important because we are sure that the shaft length expansion, because for example of thermal influence, will be compensated. Now we will go on with the next topic concerning rolling bearings. These are the seals. So first question, why sealing rolling bearings? To avoid that the bearing grease escape and also to try a constant working temperature. What are the next point therefore? To protect the bearings against entering of solid particles, liquids like dust, water, cleaning fluids, etc. There exist different types of sealings. Here on the slide we see here below 3 pictures. External sealing with contact. This is here the first picture in the slide. If we take a look on the left side, then following with external sealing without contact, and then we have here the internal sealings. Now I want to mention here the materials from which the main components of the rolling bearings are manufactured. We see here above that the outer and inner ring is manufactured by using steel bars of 100 chromo 6. The rolling elements normally are also manufactured by using the same material. But in some cases, better say, like indicated here, they are made by ceramic materials. At first, take a short look here below at the chemical composition of this material, 100 chromo 6. We see that we have a high percentage of carbon, an average of 1%. That allows us the application of a hardening procedure. The chrome value, which is also indicated in this table of the chemical composition, with a value approximately from 1.5%, increases the wear resistance. This slide, some other points concerning the material. I will resume it. Advantages. After the hardening processes, we reach a high hardness of approximate 62 Rockwell. The most applied hardening process here is the case hardening. We have also a strength of more than 100, or better say 1000 megapascal. Disadvantages here, and this is important, this is also indicated here, is the low corrosion resistance. Because of this issue, please take into account that lubrication concerning rolling bearings is not only important, if we use it in an operational modus, it is also important if we take into account the manipulation or storage of them. Example, if we store our rolling bearings in our warehouse, we must assure that they are lubricated. Now we come to the topic dimensions of rolling bearings. Main dimensions are regulated by the following norm. I write it here down: ISO 15 and ISO 104. I want to point out that rolling bearings are standardized parts. That means that all geometrical dimensions and physical characteristics like loading capacities, lifetime in hours, etc., you can find it in the catalogs of the different rolling bearings manufacturer. Here a short extract on the left side, like SKF, FAG, NSK, for example, but there exist all other manufacturers. There you will find all the necessary information. So we come to an end. At first, thanks for your attention. I hope this short introduction was useful for you. If you have any questions, please use this indicated email address here, info@machinetoolindustry.es. If you want to know a little bit more about machine tools, you can visit also my webpage, www.machinetoolindustry.es. Thank you for your attention, and I wish you all a good day.